Good morning, sir. Good morning to everyone. My name is Leela Kalyani. I am from CSE first year. Subject name physics. Today my topic is about the dipole moment, electrical dipole moment, electrical dielectrical polarization and dielectrical polarizability. First slide. Introduction to the dipole moments. Dipole moments are a vector quantity that represent the separation of a positive and a negative charges. They play a crucial role in understanding molecular interaction, chemical bonding, and material properties. The strength and direction of a dipole moment can influence the behavior of a molecules in the electrical fields. Here is the picture of the dipole-dipole interactions. Next slide. Next slide is about the defining electric dipole moment. The electric dipole moment is a specific type of dipole moment associated with the electric charge distribution. It is defined mathematically as the product of a charge magnitude and the distance separating the charges. Electrical dipole moments are a crucial circular in predicting how molecules interact with electromagnetic radiation. Here is the picture of the defining electrical dipole moment. Next slide. Next slide is about the formula of electrical dipole moment. Here is the formula of the electrical dipole moment in the picture. The formula of electrical dipole moment is given by P into Q into D, where Q is the charge and D is the distance between charges. This relation indicates that larger charges or a greater distance yield to a stronger dipole moments. The direction of the dipole moment is conventional from the negative to the positive direction. Here is the formula representation of the electrical dipole moment in the picture. Next slide is about the importance of a dipole moments in chemistry. Dipole moments influence molecular polarity, which affects solubility and chemical reactivity. They also play a significant role in the behavior of molecules in electrical fields and their interaction with other molecules. Understanding dipole moments help chemists design better drugs and materials with a specific properties. In the picture, they explain about the dipole moment in a chemistry. Next slide is about the introduction to the dielectrical polarization. Dielectrical polarization refers to the process where all electrical materials become polarized in an electrical field. This polarization occurs when the positive and negative charges within the material shift silently in response to the field. The result in a separation of a charge that creates an induced dipole moment within the material. Dielectric polarization is a process where electric material polarized in an electric field. The result in a separation of a charges that creates an induced dipole moment within the material. Next slide is about the mechanisms of a dielectric polarization. There are survival mechanisms of a electrical polarization, including electronic ionic polarization and a specific charge polarization. Here is the electric polarization occurs due to the displacement of the electron clouds in atoms or molecules. Electron polarization occurs due to the displacement of electron clouds in atoms or molecules. Ionic polarization involves the displacement of ions in ionic compounds under an electric field. Here is the mechanism of a dielectric polarization picture. There are survival mechanisms of a dielectric polarization, including electronic ionic orientation and a special charge polarization. Electronic polarization occurs due to the displacement of electron clouds in atoms or molecules. Ionic polarization involves the displacement of ions in ionic compound under an electric field. Next slide is about the dielectric constant and polarization. The dielectric constant is a measure of a material's ability to be polarized by an electric field. A higher electric constant indicates a greater ability to polarize and store electric energy. The relation between dielectric constant and polarization is essential for understanding capacitors and their applications. Dielectric constant and polarization picture is explained in this picture. The next slide is about the dielectric polarizability. Dielectric polarizability quantifies how easily a dielectric material can be polarized by an external electric field. It is defined as the proportionality constant that relates the induced dipole moment to the applied electric field. Higher polarizability indicates that a material will respond more strongly to an electric field, affecting its dielectric properties. Next slide is about the applications of a dielectric polarization and a polarizability. Dielectric polarizability are critical in the design and function of a capacitor and insulator. They are also important in communication, where materials must respond accurately to varying electric fields. Understanding these concepts can relate to advancements in material science and metrology. Conclusion and future direction. Dipole moment, dielectric polarization and polarizability are central concepts in physics and chemistry. Continued research in these areas may yield new materials with enhanced properties for various applications. Understanding these phenomena is essential for advancements in technology, particularly in electronics and material development. This represents provides a structure overview of the key concepts associated with it. Thank you, and thank you to everyone.